Next I'm going to do some of the homework problems. The first three I'm going to do are 48, 49, and 50 on page 360. The directions say, use the definition of the definite integral to evaluate the following definite integrals. Use Wright-Riemann sums and theorem 5.1. It's a reminder from the first part on summation notation. We have our rules for a constant, rules for the first in integers, first in squares, first in cubes. We're going to end up using those. The definition of the definite integral from a to b is the limit as the maximum partition size goes to 0 of x sub k star times delta x sub k, which, if the max is going to 0, we can say that the number of partitions is going to infinity. And inside this x sub k star, I replaced it with what x sub k star is for the Wright-Riemann sum. The other thing that we need to remember is our delta x, or our, is equal to the right-hand point minus the left-hand point divided by the number of partitions. So first thing we want to do is we want to write our problem out. Then the next thing we're going to do is we're going to write our this, and then we're going to fill in the blanks. So I'm going to write the limit as n approaches infinity of the summation of k equals 1 to n of f, in this case, is 1 minus x. I'm going to write 1 minus, and where the x goes, I'm going to put a, which is 1, plus k times delta x. And delta x is b minus a over n. 5 minus 1 is 4 over n times delta x, which is 4 over n. Now we need to remember what we're doing here is we're finding the limit as k goes from 1 to n. Anything that does not have a k in it is a constant. So this 4 over n is a constant, and we know that we can pull constants through summations, and we can pull constants through limits. So I'm going to pull this constant all the way through. 4 over n times the limit as n. Actually, I'm just going to pull it through the summation because we have n going to infinity. Of 4 over n. Okay, this k I'm going to replace with n times n plus 1 over 2. So that would be 1 minus, the k becomes an n times n plus 1 over 2 times the 4 over n. I'm now going to distribute this part inside the parentheses. Notice each step. So this step, I actually took the summation, turned the k into this k became n times n minus 1 over 2. So I drop the summation. I have to keep carrying the limits each time through until I actually take the limit. N times n is n squared, times 4 is 4n squared. N times 1 is n, times 4 is 4n, over 2n. Right now, this n will cancel with one of those and one of those. The 2 will cancel with that to leave that as a 2 and that as a 2. I'm now going to distribute the 4 over n. Four over n times 1 is 4 over n minus 4 times 2 is 8n. 4 times 2 is 8. This is a 1, so that's over n. I am going to rewrite this a little differently. That 8n plus 8 over n, I'm going to write as minus 8n minus 8 over n. And if you will notice that these n's cancel, and now I can actually take the limit. The limit as n approaches infinity of 4 over n, that's going to approach 0. Negative 8 over n is going to approach 0. And I get, only thing that's left inside here is the limit of negative 8 as n approaches infinity is negative 8. So we should remember that that's telling us that the majority of the area is below the x-axis. And let's see if that actually makes sense from this graph. This is a linear function with a y-intercept of 1. It's going downhill. 2, 3, 4, 5. So this is the area that we are trying to find. Well, the height is 4, the width is 4, and the area of a triangle is 1/2 times base times height, which is 16 over 2, which is 8. But because we're below the x-axis, it became a negative 8. So our answer does check. The second problem I'm going to do is number 49. We're going to follow the exact same steps. I'm going to copy my limit. The limit as n approaches infinity of the summation of k equals 1 to n of f of a, and a is 3, plus k delta x. Delta x is 7 minus 3, which is 4 over n, times delta x, which is 4 over n. So last time I directly substituted into the function. This time I wrote it as f of. You can do either method. I'm going to bring this in front of the summation sign again. The summation of k equals 1 to n. So everywhere there's an x, I'm going to put parentheses. I'm going to start out with square brackets. I'm going to write the 4 parentheses, and inside the parentheses, I write down what x is equal to. That's this part. 3 plus 4k over n plus 6. Close the square brackets. Note this 4 over n I pulled out in front of the summation symbol. Next thing I'm going to do is I'm going to distribute the 4 inside the parentheses. K equals 1 to n. 4 times 3 is 12. 12 plus 6 is 18. I might as well combine my terms also. 4 times 4 is 16. K over n. I am now going to take the summation. The summation of a constant is the constant times what I'm summing. In this case, I write the n. So I'm going to write 18n for that one. And then I'm going to substitute For k, I'm going to write n times n minus 1 over 2. So I still need the limit, but I can drop the summation. So it's the limit as n approaches infinity of 4 over n. This 18 becomes 18n. This 16k over n, the 16 and the n are going to stay the same. The k becomes n times n minus 1 all over 2. I am now going to distribute the 4 over n into each term. Four times 18 is 72, n over n. Four times 16 is 64. 64 divided by 2 is 32. Times n squared. 4 times 16 is 64, divided by 2 is 32. N times negative 1 would be minus 32n. And on the bottom, I am going to end up with n times n, which is n squared. So I already took into account the 2, so I'm going to end up with an n squared here and an n squared here. And now I can take the limit. Notice here that the n's cancel. The n squareds cancel. One of these n's will cancel. And the limit as n approaches infinity of the last term is going to approach 0. So I'm left with the limit as n approaches infinity of 72 plus 32, which is 104. The final problem is number 50. And write the limit as n approaches infinity of the summation k equals 1 to n times f of x squared. No. I need to write the a. A is 0 plus k b minus a over n times 2 over n. Then I'm going to limit as n approaches infinity. I'm going to bring this 2 over n in front. The summation of k equals 1 to n. I'm going to replace x with 2k over n. So that's x squared minus 1. I'm now going to square what's in the brackets. Limit as n approaches infinity of 2 over n, the summation, k equals 1 to n, 4k squared over n squared minus 1. I'm now going to take the summation. So I have 2 over n. And for k squared, I have n times n plus 1 times 2n plus 1 over 6. So I have 4 times n times 2n, actually I'm going to write plus n plus 1, times 2n plus 1, all over 6n squared, minus 1. 1's a constant, So I'm going to end up with a minus n. Distribute. Okay, and we should realize now that since we're taking limits, all I really care about is the highest power term of this polynomial. So when I do the distribution, all I'm going to do is I'm going to write down the highest power term of this polynomial, because that's the only one that may have an effect of my solution. So 2 times 4 is 8. N times n is n squared, times n is n cubed, times 2 is 16n cubed, plus some stuff there, divided by 6n cubed, minus 2n over n. So what I would end up here is I'm going to end up with a term that has n squareds in it. And you should note that this term that has n squareds in it is going to end up approaching 0. Then I'm going to have a term that has n's. N over n cubed is going to approach 0. And I'm going to have constant over n cubes, and those are going to approach 0. So I only need to worry about the first term. So the limit as n approaches infinity. The n cubes cancel, so I have 16 over 6, which is 8/3, minus 2, which is 6/3. 8/3 minus 6/3 would be 2/3. So I think something may be wrong with number 49. I'm going to stop this video and I'm going to redo 49.